Close your eyes for a moment and imagine a place where it rains diamonds, where the sun sings, where moons hide oceans deeper than Earth's, and where storms rage for 300 years without stopping. You're not dreaming, you're entering the solar system. Tonight, I'll take you on a gentle journey through 20 astonishing truths about our cosmic neighborhood, each one stranger than fiction, yet absolutely real. Close your eyes. Now imagine a place where the rain doesn't fall as gentle drops of water, but as glittering gemstones. Not a metaphor, not a dream, but actual physical diamonds tumbling from the sky, deep in the belly of two distant, icy worlds. Welcome to Neptune and Uranus. Far from the warmth of the sun, these two mysterious giants float silently at the edge of our solar system. They are called ice giants, though the name can be misleading. Their surfaces are not solid ice, nor are they welcoming blue oceans like our Earth. No, these worlds are more alien than we can fully imagine, filled with storms larger than Earth, and hidden within them, a secret as dazzling as it is unbelievable. Diamond rain. It sounds like fantasy, like something from a forgotten fairy tale, but it's real, at least according to what science now believes, and it begins with the chemistry of the giants themselves. Both Neptune and Uranus have atmospheres rich in methane gas. And unlike Earth, where methane is mostly found in trace amounts, these giants carry it in thick, swirling clouds. Methane is a hydrocarbon, meaning it contains hydrogen and carbon. Now, under the immense pressure and staggering heat that exists deep inside these planets, the methane doesn't stay as gas for long. As you sink below the clouds and descend thousands of kilometers into the interior of these planets, something dramatic happens. Temperatures soar to thousands of degrees Celsius. Pressures climb to millions of times higher than Earth's atmosphere. Under such extreme conditions, the bonds in the methane molecules start to break. Carbon atoms are freed, liberated by physics. And these carbon atoms, pushed together under pressure greater than anything we can replicate easily on Earth, begin to rearrange themselves. They become diamonds. Yes, actual diamonds, forged not by human hands, but by the very crushing weight and heat of a distant world. These diamonds, scientists believe, don't just sit still, they fall. Heavier than the hydrogen and helium around them, they begin to rain downward, sinking through the layers like jewels falling through honey. And as they fall, they may continue to grow, accumulating more carbon on their descent, perhaps becoming chunks the size of golf balls, or larger. Imagine that. Clouds of ice and ammonia swirling far above, a storm crackling with lightning louder than anything we've ever heard. And below it, deep inside, a shimmering cascade, diamond after.
In laboratory conditions here on Earth, scientists have tried to replicate the pressure and temperature found inside Neptune and Uranus. In 2017, researchers at the SLAC National Accelerator Laboratory in California used high-powered lasers to simulate these conditions on a tiny scale. When they blasted plastic, which is similar in composition to methane, they observed something astonishing. Nano-sized diamonds formed in just fractions of a second. It was a glimpse into the impossible. It suggested that what might sound like poetic myth is actually an ongoing geologic reality on these ice giants. But it gets stranger. Where do these diamonds go? Some theories suggest they keep falling until they reach the core, possibly forming a vast ocean or crust of molten carbon, or even a gigantic diamond center. That's right, Neptune or Uranus could have a heart made of diamond. Think about that. A planet, invisible to the naked eye from Earth, drifting silently in the void, with a glowing, searing hot diamond the size of a continent beating at its core. Isn't that a beautiful image? And yet, we may never see it directly, at least not for a very long time. We have only visited Uranus and Neptune once, when the Voyager 2 spacecraft flew by them in the late 1980s. Since then, they have remained largely untouched by human eyes, a mystery floating in the dark. But with future missions now being planned by NASA and others, we may soon peer deeper into their hidden hearts. Until then, we can only imagine. storms of glitter, skies alive with methane and blue clouds, lightning flashing across an alien sea, and beneath it all, a quiet, steady fall of diamonds, an eternal rain of precious stones.
Sculpted not by wealth or greed, but by the pure force of nature. So, the next time it rains on your window, pause and wonder, what would it feel like if every drop was a diamond?
Drift with me now, past the veil of Earth's sky, across the lunar tides, and beyond the reach of Mars. We are gliding toward the largest planet in our solar system, a giant cloaked in clouds, spinning in slow motion through the silence of space. This is Jupiter, a gas giant so massive it could swallow 1,300 Earths and still have room to spare. A planet with no solid surface, no quiet ground to stand on, just layers upon layers of wind, clouds, and storms. But among them, one storm stands out. It's not just the biggest on Jupiter, it's the biggest in the entire solar system. It's called the Great Red Spot, and it has been raging for more than 300 years. Imagine that. A storm older than the steam engine, older than the light bulb, older than airplanes, cars, or skyscrapers. It was there when Newton was discovering gravity. It was there during the birth of Beethoven, and it is still there now, spinning, slowly, defiantly, in a world of endless turbulence. The Great Red Spot is a colossal swirling vortex, an anticyclonic storm to be exact. That means, unlike hurricanes on Earth, which spin counterclockwise in the northern hemisphere, this one spins in the opposite direction, and not gently. Winds in the Great Red Spot can reach speeds of 430 to 640 kilometers per hour, fast enough to tear apart any building, crush any aircraft, and shred any vessel foolish enough to drift into its path. Yet from space, it is quiet, beautiful even. A rusty red oval set into Jupiter's pale banded atmosphere. It's about 1.3 times wider than Earth, though it used to be much larger. Centuries ago, when astronomers first observed it through their primitive telescopes, the storm may have spanned over 40,000 kilometers. Today, it measures around 16,000 kilometers across. Shrinking? Yes, but still unimaginably vast. So what fuels a storm like this? Unlike Earth, Jupiter has no solid land to slow its winds down. On our planet, hurricanes eventually break apart when they make landfall. But on Jupiter, there is no land, just endless layers of gas stretching down into deeper, hotter, and more pressurized regions. That means a storm, once born, can last indefinitely, unless something disrupts it. And nothing has. Beneath Jupiter's multicolored clouds lies a planet in constant motion. Bands of wind wrap around the planet at different speeds and in opposite directions. These bands create powerful shear forces, zones of friction and turbulence where storms are born and fed. The Great Red Spot is nestled between two of these bands, trapped in a powerful jet stream system that keeps it spinning like a gear caught in the grooves of a machine. And the colors? Ah, that's another mystery. The reddish-orange hue of the Great Red Spot has puzzled scientists for centuries. No one knows for sure what gives the storm its signature color. Some believe it may be Others think there could be exotic chemicals swirling within, unknown to Earth. Whatever the case, it's as if Jupiter painted a crimson eye upon itself, a mark of power and fury. But even the most eternal storms have secrets. In recent years, space probes like Voyager, Galileo, and Juno have given us glimpses into the storm's hidden layers. Juno in particular has flown closer than any probe before, capturing not only images but deep penetrating microwave data that reveals the Great Red Spot extends much deeper than we thought, perhaps hundreds of kilometers into the planet's atmosphere. And there's something else. Beneath the Great Red Spot, Jupiter glows with energy. The planet emits more heat than it receives from the sun. That internal heat, generated by the slow compression of the planet's own massive core, fuels its storms from the inside. It's as if Jupiter is alive with motion, spinning and swirling in its own rhythm, far removed from the quiet orbits of its moons. Yet even this monster of a storm is changing.
it's shrinking. Year by year, the Great Red Spot is getting smaller, slowly, gradually, but steadily. Some scientists wonder, is this storm nearing the end of its centuries-long life? Will it someday fade into the swirling clouds, leaving no trace that it was ever there? Or will it endure, shifting shape, growing again, reborn in another form? We do not know. But isn't that the beauty of it? To look up at the night sky, to know that on one of those tiny points of light, Jupiter, the wandering star, there is a storm older than our nations, our buildings, our technology, a storm that never knew war, never knew language, never knew peace. Just motion, just energy, just existence. So, tonight, before you sleep, listen to the wind outside your window. Let it whisper to you across the stars. Somewhere far away, a greater wind still howls, a red eye watching over Jupiter's eternal sky. Float with me now through the velvet black of space, past the sparkling rings of frozen light, and drift gently toward a world that defies imagination. Welcome to Saturn. A golden giant wrapped in icy rings, Saturn is perhaps the most poetic of all the planets, an elegant orb spinning in near silence, its curves framed by millions of shimmering particles. But deep at the top of this graceful world, tucked into its north pole, like a secret too strange to believe, lies a shape that shouldn't exist in nature. A perfect hexagon. That's right. Etched into the atmosphere of Saturn is a cloud formation shaped like a six-sided polygon, sharp, geometric, enormous. It isn't a trick of the light or an illusion caused by angles. This hexagon is real. It's stable, and it has been there for decades, possibly centuries. A storm shaped like geometry itself. The hexagon was first discovered in 1981 by NASA's Voyager spacecraft. When images came back from the icy planet, astronomers were stunned. A cloud pattern, 20,000 miles wide, had formed into a symmetrical shape, with 6 nearly equal sides rotating like a slowly turning machine. To this day, the hexagon continues to spin steadily, eerily around Saturn's pole. A storm within a storm, clocking wind speeds of nearly 320 kilometers per hour. And in the center of it all, a mysterious dark vortex, like the eye of a cyclone that no Earth weather could ever match. But how? How can nature, so often chaotic and random, produce such clean, sharp lines? How can gases, swirling in the fierce winds of a gas giant, somehow settle into perfect geometry? The answer lies in fluid dynamics, but also in wonder. You see, gases can behave like liquids when flowing in circular patterns. In labs here on Earth, scientists have recreated miniature versions of this effect by spinning fluids in cylindrical containers. When the liquid is rotated at just the right speed and under specific temperature and pressure conditions, patterns begin to emerge, some triangular, others square, and sometimes even hexagonal. Saturn, it seems, is conducting the same experiment, on a scale beyond anything we could imagine. But this isn't just a curious shape, it's a living system. The hexagon isn't a flat pattern, it reaches deep into the atmosphere, towering tens of kilometers above Saturn's cloud tops. It rotates as a single unit, yet inside, smaller storms churn independently. Sometimes its colors shift, turning from a cold blue to a golden hue, as Saturn's 29-year orbit brings summer sunlight back to its northern hemisphere. The colors change because of photochemical reactions caused by sunlight, changing the gases like a mood ring glowing in the void. The Cassini spacecraft, which orbited Saturn from 2004 to 2017, gave us breathtaking views of this hexagon. It flew directly over the pole, capturing high-resolution images, revealing the storm image.
Invisible light. It looks like a geometric flower blooming in gas, but even Cassini couldn't answer all the questions. Why a hexagon and not another shape? Why does it remain so stable? What keeps its edges so sharp, resisting the tendency to blur like every other storm in the solar system? We're still searching for answers. One theory suggests that different wind speeds, jet streams, moving at varying latitudes on Saturn, interact in such a precise way that they naturally form a standing wave pattern, like ripples frozen in time. These patterns can solidify into polygons when all the forces align: forces of temperature, pressure, and planetary rotation. Yet no other planet has shown anything quite like this. Not on Jupiter, not on Neptune, not even on Earth, only Saturn wears this hexagonal crown like a symbol of its icy majesty. It feels almost alien, like a message written in math waiting to be understood, or a cosmic fingerprint left behind by a force beyond our grasp. But maybe that's what makes it so mesmerizing. We are used to seeing chaos in the cosmos: explosions, regularities, collisions, dust, and debris. But here, high above a planet, made of swirling gas, nature whispers something else: that symmetry and chaos are not opposites, but partners. Now, that even in the wildest places, order can emerge like a snowflake falling into place. Imagine standing at the edge of Saturn's pole. You look out into clouds painted in gold, spinning gently beneath you. And just ahead, a six-sided storm, moving silently, endlessly. The wind doesn't howl, it hums. The shape doesn't blur, it holds. Time slows down. The geometry of nature reveals itself not in formulas, but in form, the great hexagon etched into the sky of a ringed giant. So the next time you see a honeycomb, or a snowflake, or the facets of a crystal under soft light, remember, far beyond our skies, Saturn is keeping time with its perfect storm. A six-sided symphony in a world of eternal wind. Close your eyes, breathe deeply. You are drifting beneath golden clouds. Imagine standing on a distant, cloud-wrapped world. The sky above you isn't blue, it's heavy, golden and thick with toxic mist. The surface beneath your feet is scorched rock, forever baking under an oppressive atmosphere. You wait. Wait, and still, the sun does not rise. You're on Venus, and here time moves differently. Venus, often called Earth's sister planet, is about the same size and made of the same rocky materials. But that's where the similarity ends. 4. While Earth spins briskly, rotating once every 24 hours, Venus takes its time. So much time, in fact, that a single day on Venus lasts longer than its year. Let's break that down. A year on Venus, the time it takes to orbit the Sun, is just 225 Earth days, but a Venusian day at the time it takes the planet to complete one. Full rotation on its axis is a staggering 243 Earth days. Yes, a full day is longer than a full year. It's one of the strangest rhythms in the entire seventh. And if that weren't curious enough, Venus rotates backwards, unlike most other planets which spin counterclockwise, as seen from above the North Pole. Venus spins clockwise. So if you could see the sun from the surface, it would appear to rise in the west and set in the east. It's opposite from Earth. But don't expect to actually see the sun. Venus is wrapped in a thick, permanent blanket of sulfuric acid clouds so dense that sunlight barely makes it through. And yet these clouds trap heat like a greenhouse gone mad. Venus is the hottest planet in the solar system, with surface temperatures around 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt lead, hotter even than Mercury. Though Venus is further from the sun, and beneath those clouds, a stillness unlike anything you've ever known. The surface air pressure is over 90 times that of Earth, equivalent to standing more than a kilometer under the ocean. Space probes that have landed there survived only minutes before being crushed, melted, and silenced. But let's come back to time. Why does Venus spin so slowly? Why does it turn in the opposite direction? The truth is, we don't fully know. Some scientists believe that long ago, Venus may have been hit by a massive object, something that slowed it down or flipped its rotation entirely. Others think tidal forces from the sun may have gradually twisted and decelerated its spin. Still others suggest complex atmospheric effects and internal dynamics at play. Whatever the reason, Venus ended up with a rhythm so strange, it borders on surreal. Now here's where it gets even more fascinating. While a sidereal day on Venus is 243 Earth days, That's one full rotation. The time between sunrise is called a solar day is only 117 Earth days. This happens because of the interplay between its slow spin and its orbit. So, even though Venus rotates slowly, the Sun actually appears to rise and set twice per Venus year. The result is a planet where time loops like a spiral, where days crawl and years race, where the clockwork of heaven runs in reverse. Imagine living there. You wake up in eternal twilight. The sky is orange, glowing faintly. You wait for the sun, but it doesn't come. You grow old before it finally peaks over the hazy horizon. A lifetime could pass between dawn and dusk. Time as you know it loses meaning, and yet somewhere beneath all that heat and pressure, Venus may still hold secrets. Some scientists believe it may have once been Earth-like, with shallow oceans and a gentler climate, but a runaway greenhouse effect fueled by carbon dioxide may have boiled away all its water, leaving it scorched and bone dry. A warning, perhaps, from a sister planet that fell too far out of balance. Today, Venus fascinates astrobiologists, not because it's habitable, but because its upper atmosphere might hold hints of life. High above the deadly surface, in the cool, drifting clouds, temperatures and pressures are milder. In 2020, a team of scientists detected phosphine, potential signature of microbial life, though it remains controversial. Still, Venus continues to whisper. Not loudly. Not in explosions or light, but in time, in the slow turning of its body and its backward dance around the sun, in the haunting truth that a day here lasts longer than a year. So tonight, as you drift into sleep, think of Venus spinning slowly in silence. A planet that redefined our sense of time. A place where sunrise may come once in a lifetime. A world lost in golden clouds and endless heat, and yet still orbiting, still turning, still dancing beneath the sun, in a rhythm only it knows. Breathe slowly. Now imagine walking across a quiet, rust-colored desert. Now the wind is thin, whispering over the sand, carrying with it the ancient hush of a planet that remembers everything. And on the horizon, something rises. Impossibly tall, so high that it curves with the planet, so wide it stretches beyond your vision. Welcome to Olympus, MONS, the tallest volcano, and the tallest mountain in the entire solar system. It towers 22 kilometers, 13.6 miles above the Martian surface. That's nearly 2.5 times the height of Mount Everest. From base to summit, it is so massive that if you stood on the edge, the peak would vanish beyond the curve of the horizon. It's not just tall, it's wide, stretching 600 kilometers, 373 miles across, but the size of the entire state of Arizona. But unlike Earth's towering, jagged mountains, Olympus Mons is gentle and slope. You could walk up it without ever needing to climb. You just keep walking upward. For days, how did such a mountain form? To understand, we need to peer into Mars's past. Mars is a planet of fire and frost. Billions of years ago it was. Volcanically active rivers of lava once flowed across its surface, reshaping the land. Olympus Mons was born during this fiery era through repeated eruptions of lava that slowly piled atop each other. But on Earth, mountains can't grow forever. Our planet's surface is broken into shifting tectonic plates, which move and recycle. The crust. When a volcano erupts here, it might only build up so high before the plate shifts it away from its hotspot, halting the eruption and moving the mountain. But Mars has no tectonic plates. Its crust is one giant rigid shell. So when a hotspot forms deep in the mantle, it stays in place for millions of years. Eruption after eruption continues in the same spot, building layer after layer of rock until a mountain like Olympus Mons emerges silent, immense, and timeless. And Mars's weaker gravity helps too, with only about 38% of Earth's gravity. Mars allows mountains to rise higher without collapsing under their own weight. It is a world that nurtures giants. But what's even more incredible is that Olympus Mons is not alone. It's part of a vast volcanic region called the Tharsis Plateau, home to several other giant volcanoes: Zoscrius Mons, Pavonis Mons, and Arsia Monsal, nearly rivaling Olympus in scale. This region, swollen and lifted by ancient magma, reshaped the face of Mars and may have even tilted the entire planet in its past. Olympus Mons is so large that it creates its own weather. The air at the summit is far thinner and colder than at the base. Clouds sometimes form around its rim. And while it's thought to be dormant now, some scientists believe it might still be active, a sleeping giant beneath. A blanket of red dust. Imagine standing on its slope. The ground beneath your boots is ancient lava, cooled and cracked into endless ridges. The sky above you is pale pink. In the distance, the sun is smaller than on Earth, glowing dimly over the thin horizon. And everywhere around you, silence. A silence not of emptiness, but of waiting. Mars has known this mountain for billions of years. It has seen stars rise and fall, moons drift across its skies, and dust storms sweep across its plains. It has held this monument of fire through ages of stillness. It has never let it go. But why does it matter? Why should we care that Mars holds the tallest volcano? Because it tells a story. It tells us that Mars was once alive with molten heartbeats and burning breath. That it built wonders not through chaos, but through patience. That even in a world so quiet today, there are echoes of power frozen in stone. And maybe one day, we'll stand there. Human explorers may climb its slopes, placing boots where lava once flowed. They may build shelters near its base, using its cliffs as shields against radiation. Olympus Mons may one day watch us return to fire, to harness energy from a world that once boiled with it. Or maybe it will remain as it is now, silent, sacred, unmoved. A mountain not just of rock, but of memory. So tonight, as you drift toward sleep, think of Mars not as cold and dead, but as a place of giants, where volcanoes touch the stars, where the past rises into the sky, and where Olympus Mons still stands. Quietly, in the thin Martian air waiting, breathe slowly. Now drift far from Earth, past Mars and Jupiter's roaring storms, beyond the warmth of the sun's golden pull. We arrive at a moon small, pale, and quiet. But beneath its frozen shell, a secret stirs in the dark. This is Europa, one of Jupiter's largest moons. At first glance, it doesn't look like Mucha, smooth, icy sphere etched with long brown cracks, like an ancient marble. There are no mountains here, no volcanoes or oceans you can see. Just a vast plain of ice stretching across its entire surface. But what lies beneath that ice is one of the greatest mysteries in the solar system. Europa holds more water than Earth. Yes, this little moon, barely 1/4 the size of our planet, hides beneath its crust a global ocean of liquid water. Scientists believe this ocean may be 100 kilometers deep, 10 times deeper than Earth's Mariana Trench. And unlike Earth's oceans, which cover about 70% of the surface, Europa's ocean is everywhere, encircling the entire moon in a thick subsurface sea. That's more than twice the volume of all of Earth's oceans combined. But how do we know it's there if we can't see it? The first hints came from the Voyager missions in the late 1970s, when Voyager flew past Europa, captured images of a strange, bright surface, almost entirely free of craters. That was the first clue. A young, dynamic crust, one that might be moving, cracking, healing. Later, the Galileo spacecraft orbited Jupiter in the 1990s and passed Europa multiple times. It found more clues. Magnetic field measurements suggested that something salty and conductive lay beneath the ice. The surface showed patterns of cracking and shifting as if floating on a vast liquid layer. Some regions looked like icy tectonic plates, broken and rearranged like a frozen version of Earth's crust floating on a hidden sea. Then came the most astonishing find: plumes. In 2012, the Hubble Space Telescope detected signs of water vapor erupting from Europa's south pole, like geysers on Earth. These plumes were shooting into space, suggesting that the ocean below wasn't just still, it was alive with motion. Since then, multiple missions have hinted at recurring water jets. A moon once thought to be silent was now whispering to us, spraying salty water into the void. Imagine that, a frozen moon, cracked and cold on the outside, but underneath, a restless ocean, warmed by invisible forces moving in darkness. But how does the water stay liquid so far from the sun? The answer is tidal heating. Europa orbits Jupiter in a slightly oval path as it swings closer and farther from the gas giant. Jupiter's immense gravity stretches and flexes the moon's interior. This constant tug-of-war creates friction, heating Europa from the inside out. Much like how bending a paperclip repeatedly can make it hot, that internal warmth prevents the ocean from freezing solid. Instead, it keeps the water below the crust. In a liquid state, may be warm enough to support hydrothermal vents, similar to those on Earth's ocean floor, and that leads to the most exciting question of all. Could there be life? Here on Earth, life thrives in places without sunlight, in deep ocean trenches, near hydrothermal vents, where bacteria feed on minerals rather than sunlight. These are alien ecosystems, dark and extreme, and yet full of life. Could something like that exist on Europa? It's one of the most compelling possibilities in modern science. Europa's ocean may contain the three key ingredients for life: liquid water, energy, and chemistry. If it has hydrothermal vents at the sea floor, it could be the perfect cradle. For microbes or something more complex, we don't know yet, but we're about to find out. NASA is preparing a mission called Europa Clipper, set to launch in the coming years. It will orbit Jupiter and perform dozens of close flybys of Europa, using radar to peer beneath the ice, sniffing for molecules in any plumes, and mapping the moon's surface in unprecedented detail. It won't land yet, but it will bring us closer than ever before to the truth. And maybe one day, we'll send a probe to land, to drill down through the ice, to taste the ocean, to listen for signals in the water, to meet what may be swimming in the dark. Just think about that for a moment. A world smaller than our moon, floating in the cold shadow of Jupiter. It's maybe teeming with life beneath its frozen skin. So the next time you pour yourself a glass of water, or listen to the rain, or stand by the sea, remember Europa, a silent moon glittering with ice, hiding an ocean deeper and wider than anything on Earth. An entire world of water, waiting. Close your eyes and imagine the sun, not the blazing ball of fire you've seen in science books, nor the distant glare that warms our mornings, but the sun as a living, breathing instrument. A bell ringing softly, rhythmically every few minutes. Yes, our sun sings. Not in the way we hear sound on Earth, but in deep, powerful waves, giant pulses that ripple through its body in silence. These waves move through plasma, the hot charged gas that makes up the sun, causing it to expand and contract in patterns so precise, so structured, they resemble the sound waves of a musical instrument. The sun rings like a bell every 5 minutes. It pulses in and out thousands of times a day. Surface rises and falls ever so slightly, resonating with energy. We cannot hear it with our ears because space is silent. But scientists have found ways to listen. And what they've discovered is as beautiful as it is mysterious. This phenomenon is called helioseismology, the study of waves on and within the sun. Just as geologists use earthquakes to study Earth's interior, astronomers use the sun's vibrations to explore the layers hidden beneath its surface, and what they found is music, solar music. These oscillations were first noticed in the 1960s, when astronomers observed strange flickering patterns on the sun's surface. At first, no one knew what they were, but over time, they realized that these were not random flickers. They were waves, massive acoustic waves traveling through the sun's body, bouncing around its core, refracting and echoing through its outer layers. The sun doesn't produce just one tone. It rings with millions of different frequencies at once, like an orchestra warming up before a concert complex, layered and rich. The high-frequency waves vibrate through the surface, while the low-frequency waves reach deep into the sun's interior. These waves are born from the convective zone, the outer third of the sun, where hot plasma boils and churns like a pot of water. Columns of heated gas rise up, cool at the surface, and fall again in a never-ending loop. These movements create pressure, changes essentially. sound waves which then reverberate throughout the sun's entire structure. The sun becomes an instrument not made of strings or reeds, but of light and plasma and gravity. And though we can't hear it directly, scientists have translated the sun's vibrations into sound using computers. When played back, the sun's tones sound like a deep, humming gong, constant, resonant, and powerful. Not chaotic, not random, but deeply ordered, like the heartbeat of a star. Imagine standing in space. Just outside the corona, where the solar wind begins to whisper, you wouldn't hear the ringing, but you might feel it, the slow, soft pulsing of the sun's breath. Like a drum beat echoing through the void, helioseismology has done more than revealed the sun's hidden music. It has allowed scientists to peek into its otherwise invisible interior. Just as doctors use ultrasounds to see inside the human body, astronomers use the sun's vibrations to map its inner temperature, density, and rotation. They've discovered that the core of the sun spins faster than its surface. They've traced flows of plasma twisting in spiral loops. They've watched sunspots form and fade, riding waves of deep solar rhythm. In fact, through this silent music, we've learned that the sun's magnetic field, responsible for solar flares and coronal mass ejections, also pulses in long cycles. It's influenced by deep internal oscillations. All of this from listening, not to light, but to the music beneath the light. And it's not just our sun. Other stars sing. 2. Through a field called astroseismology, scientists are now studying the vibrations of distant stars, H1, with its own rhythm, its own voice, its own stellar melody. Some ring faster, others slower, some with sharp pitches, others with soft ghostly hums. It's as if the galaxy is filled with a quiet, hidden choir, millions of stars, each pulsing in its own time, its own key. Even in silence, the universe is full of sound. So what does this mean for us? Perhaps nothing in terms of day-to-day life. The sun's ringing doesn't affect the tides or seasons. But in another way, it means everything. It means that even the most violent and powerful objects in the cosmos can move with grace, with rhythm, with harmony. It means that the sun, so often seen as a raging inferno, is also elegant. And perhaps most of all, it reminds us that music isn't a human invention. It's written into the fabric of the universe. From the hum of atoms to the song of a star, everything vibrates, everything sings. So tonight, as you lie in bed, eyes closed and mind adrift, picture the sun not as fire, but as a bell, ringing softly, faithfully, every 5 minutes, across the deep silence of space. Let your thoughts float gently. Drift past the planets, past Saturn's rings and Jupiter's storms. Further still, into the silent outer reaches of the solar system, where icy bodies slumber in the dark. Among them is one small, ancient, mysterious, a cosmic wanderer wrapped in something almost impossible to believe. Its name is Comet 17P, Holmes. At first glance, it seems unremarkable. A standard short-period comet that orbits the sun every 7 years or so. Rock and ghastly, a few miles wide. Tiny, really, in the grand scale of the solar system. But in 2007, something extraordinary happened. Comet Holmes exploded. Not in the fiery way we usually imagine. There was no crash or collision, no sudden burst of heat. Instead, in October of that year, this quiet little comet suddenly erupted, releasing a vast cloud of gas and dust that expanded at breathtaking speed. In just 36 hours, the cloud had grown to over 500,000 miles across, within days. Its atmosphere was bigger than the sun. Yes, you read that right. This humble comet, which could comfortably fit inside a city, had produced a glowing Coman envelope of gas so large that it dwarfed the sun itself. The sun, which measures about 1.4 million kilometers, 870,000 miles in diameter, was briefly outmatched in size by a comet no larger than a mountain. But how is that even possible? To understand, let's look at what a coma really is. When a comet nears the sun, its frozen surface made of water, carbon dioxide, ammonia, and other volatile compounds begins to warm up. The heat doesn't just melt the ice, it causes it to sublimate, turning directly from solid to gas. This gas, along with dust particles trapped inside, jets out from the comet's nucleus and forms a glowing envelope around it. This is the coma, the atmosphere of a comet. Normally, this coma is small, perhaps thousands of kilometers wide. But occasionally, under just the right conditions, something triggers a runaway event. A pressurized pocket of gas suddenly escapes, or a fragile outer crust collapses. The comet vents its insides in a dramatic expanding bloom. That's exactly what happened with Holmes. When it erupted in 2007, its brightness increased by a factor of 1,000,000, so much so that it became visible to the naked eye. Even from light-polluted cities, night sky watchers were stunned. What had been an invisible speck suddenly became a glowing star in the constellation Perseus. But the real magic wasn't in the light, it was in the scale. As the gas and dust spread out into space, it formed a gigantic spherical cloud that kept growing and growing. Astronomers using radio and infrared telescopes watched as the coma passed.
1.4 million kilometers in diameter, matching the width of the sun, and then growing even larger. And yet the comet's nucleus, the actual body at the center, remained
No bigger than a few kilometers. Speck inside a cloud. It was like watching a single candle suddenly envelop an entire city in mist. The cloud glowed faintly, not from heat but from sunlight scattering off particles. This is what gave Holmes its eerie, ghost-like beauty, a soft, golden fuzz drifting through the night sky, growing larger and fainter as the days passed, and then, just as silently as it had bloomed, it faded away. The particles dispersed. The gas thinned out. The coma evaporated into the void. Within weeks, Comet Holmes had returned to invisibility, leaving behind no trace except in memory and data. But the lesson it left behind remains astonishing. Size isn't everything in space, eh? Tiny object, under the right conditions, can rival the sun itself. Not in mass, not in heat, but in presence, and it raises deeper questions. How many other comets are capable of such events? Could comets like Holmes have delivered water or even organic molecules to early Earth? Could these icy wanderers, so small and so often ignored, have played a role in shaping life as we know it? And more poetically, isn't there something beautiful about the smallest bodies casting the widest shadows? A comet, invisible one night, becomes a glowing beacon the next, a reminder that transformation can happen at any moment. That in space, as in life's stillness, is not always silence, and size is not always power. So the next time you gaze up at the night sky, know that one of those faint stars might not be a star at all, but a cometa, sleeping giant, waiting to bloom again. And maybe, just maybe, it will once again carry an atmosphere larger than the sun. Close your eyes. Now imagine you are standing at the edge of the solar system. Sun is nothing more than a pale star behind you. Silence surrounds everything. And just ahead is a tiny frozen world you were once told was a lifeless rock. But it's not. Pluto, for so long, it was nothing but a name, forgotten outpost, a blurry pixel on a telescope. And then, in July 2015, something extraordinary happened. NASA's New Horizons spacecraft flew past Pluto, and everything we thought we knew changed forever, because Pluto is breathtaking. It has mountains that soar up to 11,000 feet tall. It has vast plains of nitrogen ice, as shifting glaciers, possible ice volcanoes, and a thin but real atmosphere that scatters sunlight in the most unexpected way. Pluto has blue skies. Yes, like Earth. Like a summer afternoon or a dream remembered. As New Horizons sped away after its brief encounter, it turned its camera back for one final glance, and what it saw stunned scientists and stargazers alike. A glowing haze wrapped around Pluto's edge, illuminated by the distant sun. When the data came back and the colors were rendered, the haze appeared blue. Why blue? Because of the way light scatters. Even though Pluto's atmosphere is thinner, a million times less dense than Earth sits, made mostly of nitrogen, with traces of methane and other gases. As ultraviolet sunlight strikes these molecules, they break apart and reform into complex hydrocarbons called tholins. These tholins clump into tiny particles that are just the right size to scatter blue light more efficiently than red, just like the air molecules in Earth's atmosphere. So when you look up from Pluto's surface view, you could stand there and breathe in the cold stillness. You'd see a faint but real blue sky stretching above jagged peaks. And those peaks, they're covered in snow, but not the kind we know. On Earth, snow is made of frozen water. On Pluto, it's a whole different story. The snow that falls and settles on Pluto's mountains is actually frozen methane. Oddly enough, it falls on the mountaintops rather than the valleys. Why? It's an atmospheric mystery. On Earth, cold air sinks into valleys, allowing snow to accumulate in lower elevations. But on Pluto, the process may be reversed. Methane gas in the atmosphere condenses more icily at higher altitudes, clinging to mountaintops and ridgelines where the thin air and low pressure encourage it to freeze. The result is stunning. Snow-capped mountains beneath a blue sky in a world 5 billion kilometers from home. It's a picture that seems impossible. How could something so far, so cold, so distant, be so beautiful? Pluto orbits in the Kuiper Belt, a vast, icy region beyond Neptune, filled with frozen remnants from the solar system's formation. Temperatures on Pluto average around minus 230 degrees Celsius. It takes 248 Earth years to complete one orbit around the Sun. And yet, in all that darkness and chill, dances with color and complexity. New Horizons showed us deep canyons, layered hazes, and smooth plains shaped by active geology. It revealed a giant heart-shaped basin, Tombaugh Regio, named after Pluto's discoverer, which may still be evolving today. Beneath the crust, scientists believe there may even be a liquid water ocean, preserved by internal heat or pressure from exotic ices. Yes, even Pluto might have an ocean, and the blue skies. They are not just for show, they mean something. Mean that Pluto's atmosphere is dynamic, changing, rising, falling, creating layers of haze that shift with the seasons. They mean that sunlight still reaches out that far, scattering in soft blue halos across a world once thought to be lifeless. The farther we look, the more lifelike the universe becomes. Once Pluto was dismissed a dwarf planet, too small to matter now. Now we know it has weather, it has geology, it has mountains, glaciers, skies, and snow. It has mystery. It is not empty. It is alive in its own quiet, its frozen way. So tonight, as you fall asleep, think of Pluto. Think of a blue twilight sky arched over methane snow. Think of sunlight, pale and distant, still warm enough to sculpt a world. Think of mountains, casting long shadows over nitrogen plains. Think of silence, and the hush of snow falling where no one has ever walked. The universe isn't cold, it's deep and waiting, and filled with beauty in places we never thought to look. Imagine the planet closest to the sun. You'd expect fire, scorching heat, endless deserts of molten stone. A world too bright, too dry, too dead to hold anything gentle. But what if I told you Mercury has ice? Yes, ice. Real water ice, shimmering in the deep shadows of this sun-scorched world. Let's drift there together. Mercury is the smallest planet in our solar system. A dense, rocky orb, only slightly larger than our moon. It races around the sun in just 88 Earth, days blazing through space, at nearly 48 kilometers per second. Daytime temperatures soar to over 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead, and yet, some places on Mercury, it's so cold that ice never melts. How? The secret lies in shadow. You see, Mercury has no tilteds. Axis is almost perfectly upright. Unlike Earth, where the sun's angle changes with the seasons, Mercury's poles remain in constant twilight. And because the planet has almost no atmosphere, no air to circulate heat, there's nothing to spread the sun's warmth across its surface. Now imagine Mercury's north and south poles, cratered, silent, frozen in eternal shade at the bottoms. Of these deep craters, the sun never rises, not even once. These regions are locked in permanent darkness, so cold that temperatures can drop to minus 170 degrees Celsius, minus 275 degrees Fahrenheit. That's colder than Pluto on some days. It's colder than anywhere naturally found on Earth. And it's in these deep black craters that we've found ice. Real. Bright, reflective water ice, first hinted at by Earth-based radar in the 1990s. Then, confirmed by NASA's Messenger spacecraft in 2012, Messenger orbited Mercury for 4 years, scanning its surface with instruments capable of detecting hydrogen reflectivity and temperature. What it found was astonishing. Dozens of craters near. The poles contained deposits that reflected radar waves just like ice does. And in some craters, Messenger even detected signs of organic compounds, molecules made of carbon and hydrogen, similar to those that build life. But where did this ice come from? There are two leading theories. One, comets and asteroids. Throughout the solar system's history, Mercury has been bombarded by icy space rocks. When these objects collide with Mercury, they vaporize instantly, but if the water vapor drifts into a cold, permanently shadowed crater, it can freeze there and stay frozen, undisturbed, for billions of years. The second theory, hydrogen from the solar wind. Mercury's surface contains oxygen locked in rock. When solar wind particles, streams of hydrogen from the sun, hit the surface, they can react and create hydroxyl O and eventually water HO. Under the right conditions, some of this water may migrate and freeze in polar shadows. Either way, the result is the same: a world of fire. Holding on to ice, it's poetic. Mercury, the Roman god of speed, of messages, of motion. A planet we once thought barren, lifeless, scorched. But now, we see something softer, quieter, more complex. Because ice means something survived. It means that even in the hottest place imaginable, there are pockets of stillness. Places so calm, so hidden, that sunlight has never touched them. Places where time seems to pause, where light fails, but water endures, and the ice doesn't glisten. It doesn't sparkle like a mountain glacier, or shimmer like a frozen lake. It simply waits. Quiet, it's invisible to the eye, resting in eternal darkness. This ice has never melted, never felt warmth, never been seen directly by human eyes. Yet it holds clues to where water may exist elsewhere, and how the building blocks of life travel across the stars. Even now, new missions are on the way. The Bepi-Colombo mission, a joint effort between ESA and JAXA, is en route to Mercury. It will arrive in the coming years, equipped with better instruments to study the planet's surface and polar regions in more detail. We may discover new ice deposits. We may even find how deep and how pure they really are. So imagine this. Standing at the rim of a crater on Mercury's pole, the sun burns bright in the distant sky, but just beyond the ridge lies complete darkness. You peer over the edge and see blackness that has lasted for billions of years. Down there, untouched, a hidden glacier rests protected by shadow. Untouched by time, a single snowflake frozen in a furnace. This is the lesson Mercury gives us, that the extremes can coexist, that fire and ice are not enemies, that even the most blistering world can have pockets of perfect stillness. So next time you sip a cold drink under the hot sun, think of Mercury, the closest planet to the sun, where ice refuses to melt, where darkness holds onto something delicate, where silence is colder than space and water waits beneath the flame?